Hello and welcome to the heat session of today. Together with my colleague Julian, we are both working in the product management here at PROBAT. We want to highlight a very interesting topic that is called intelligent sensors. And we go through this topic with some details regarding a general focus, what are sensors and what is the purpose of them, what data is measured or are measured, and then we move to the entire topic to the roasting plant and describe what happened there.
Yeah, yes, indeed.
So, Julian, maybe we can give it a better scope to understand what we are doing today.
Yeah, sure.
Let's talk about the database workflow, so where the data comes from and how it is processed and what we are doing with these data. So in the first step we have a sensor and the sensor is measuring the relevant data and give it then to, let's call it an information processing device. In the most areas it is a computer or something like that. And there the information is processed, is validated, it is compared to with target limits, etc., etc. And then based on these values, it can be that we have to control an actuator, which then have a direct influence on the process.
Yeah.
Do you want to add something on that, or?
Yeah, yes, indeed, of course. The actuator in itself is the moving part that makes something happen. And always when we make something happen, we have a process, which is the last point in the circle in place. So, for example, roasting coffee is a very intricate process and the backbone of PROBAT. And this is a circle that in itself controls most of the plant, because we have always a process that needs to take place, and to control or monitor the process we go over to the sensor, then process the intelligence, feedback to an actuator, and so we keep the whole gears turning.
Yep.
And thanks for showing us the way into this very interesting topic, the data-driven sensors we have in our control system. And now to kick over, I would just quickly show the central hub where all the process data comes together, which is our plant control system, the pilot plant control system. I would say I take it over from here and meet you downstairs in a minute.
Let's see you in a minute.
Okay, bye. So, please everyone, I would like to switch monitors just for a quick second. And as you can see here, this is our control system, which is now currently operating the green plant, green coffee receiving area, and every green dot or even every yellow dot we see are different data generating points. In this overview, you see partly every sensor, and we will get into the details what every sensor is and what it does and what the benefit is for you as the customer, just downstairs with Mark, and I will give over to him. Thank you.
Okay, thank you, Julian, for this nice description of the pilot software. Now we would like to jump over to the entire topic, and now we have moved from the control room now into our technical center here in front of our beautiful Netune 1000. And from this place we are going to discuss the topic we have introduced at the beginning. So maybe, Simon, we can have a view on the slide we have created. So what we have seen at the beginning of the session is that we have a lot of values or data that are necessary to run a coffee roasting plant or a coffee processing plant. And in this case, we have more than 20,000 data points in a common roastery with various purposes. So some of them have the purpose to assure a better or a consistent quality. Others are to run the processes in an efficient way, to control the processes. Some have the purpose to track or to monitor the logistic point. And at the end, of course, machine availability, so regarding service activities, are there any dangerous circumstances that can occur? All this addressed by the point machine availability. So in the meantime, Julian has joined me.
Yeah.
Welcome back.
Thank you.
Yeah, maybe we can direct start. In this slide you can see the red points we have marked here. These are the relevant points to highlight some of the values and some of these hidden sensors that we have integrated in the plant. Yeah, and we would like to start at the green coffee processing area.
Yeah, thanks for the great introduction, and yeah, not only showing us the process behind the whole plant control system and why we do everything, and the 4 pillars of yeah, quality assurance and the process control, the logistics and machine availability that is the key of operation inside the whole plant. And now I will go ahead and on the given example on the green coffee processing part, pick out examples and go over dot by dot on different small little sensors that help the whole process to be controlled and to operate smoothly, and to keep the whole production system running. On the example you already said, I would like to focus a bit on the intake process, which we all know that coffee comes in sacks and is then the sacks get emptied and conveyed into the whole plant. And here we find an interesting component, which is an elevator. And we all know an elevator is just a mechanical conveyor, but it's not just a mechanical conveyor, because this small little conveyor also operates on a lot of sensors. For example, we have the slippage control sensor, which detects different angles the elevator is running on, and ensures safety and machine availability, and also highlights maybe a maintenance point. Also, we have the revelation monitoring to see, is the component working properly and is it still conveying or not. And then we have in the motor control, we have a frequency diverter. This is also a way to regulate the whole operation of the elevator for maximum performance and also an efficient process.
And is this elevator, because we are talking, you said it before, we are talking just about an elevator, but you just mentioned several sensors or little gizmos that are monitoring any kind of value. So it is an important device in the whole plant, because if something isn't going wrong or isn't doing well, then the entire plant can be down. Maybe, for example. Because we do not get any raw coffee, any green coffee, and then we can't roast our something like that.
Sure, and this is why we always operate in an area. For example, the revelation monitoring, we have values that should be targeted, and we have
limit values like that.
Yeah, we have limit values in which we operate, and then we go and pick up on them and regulate them to be the exact best optimum operation value. Yeah, and from there on, if we go one step further in the process of the plant, we have the silo area, which we also have small little, as you nicely said, gizmos, small little sensors that help operate the plant to its maximum potential. In the storing area, we have like level sensors to keep track of every ounce, every kilogram of coffee that is inside the silos itself, and we have, for example, the radar system, or like small little paddle detectors that detect the level inside the silo to help you enable a very good planning capacity for what your next roast can be. And also beneath the silo we have our intelligent weighing system, which communicates with a sliding gate in a very intelligent way to always dose the exact coffee that you requested inside the plant control system. And there we have a linkage between the weighing cell, which itself also is an intelligent sensor, and the sliding gate, which also is equipped with precisional sensors. And there we have a self-learning algorithm to be precise and deliver the best logistics possible, for example.
And what is also important, I guess, when we're talking about traceability and logistics, that we have direct connection to the ERP system via our plant control software, where we can exactly see what is inside the silo, which kind of coffee bean, etc., etc. So we can have a lot more information than just how is the plant going. So the entire information about what kind of green coffee is there, and additional information, moisture, I guess. So the whole bunch of information is available on a digital way.
Yeah, sure. And for a way to be capitalized on. This is always the foundation why we put sensors. It's to capitalize from them and to make the process and the system as smart and as robust according to you described it, the 4 pillars of operation that are bringing the value behind each and every sensor. If we then go on maybe to the next point we highlighted in the presentation, we are in the filter area in our example plant, you can see there, and here we are in a more, some customer may say more a secondary area, because it's just to get rid of stuff we don't want.
But important.
Yeah,
we must say that.
Yeah,
it's very important.
It's very important.
In some cases of the world, less important, but in some very, very important. So we need to highlight it.
It's very important, I think, all around the world, because they are safety devices.
Of course.
And this is why we control them and measure them very accurately and tightly. We have a pressure measurement inside our filter systems, which indicate maintenance services if filters are clogged or need to
be replaced.
Need replacing, extra maintenance, and so on and so forth, to ensure that the dust gets out. And this is also an issue of quality, because roasting dusty product also does not enhance the final result of the roasted coffee. Also, we have spark detection with together with the filter system itself is another safety device, taking measures in the spark detection to give back, give the feedback to, okay, here we maybe have a problem with the roasting, or have another like point inside the whole plant that needs care or needs maintenance. And this little device or little sensor brings you a lot of safety for the whole system not to collapse in case of a spark that is that might go through to the filter system and then may cause even largest amount of damage. Yeah, this is a key one, I think personally, for every system.
Yeah, and it is closed then to the central element of the entire roasting plant, the roasting system, and we have also there a direct connection.
Yeah.
To achieve the highest amount of safety.
Yeah.
In instance.
Yeah, and this is a nice bridge maybe then to go over to the fourth point, the roasting system.
The roasting system, yes. In the roasting system, as an central element, maybe we can address, I guess, more three of the four pillars. In the first, I want to highlight the process control and efficiency element, or the pillar. We have, of course, the level indicators of the hopper, which indicates is the right amount of coffee filled in the machine, or is there any failure in the intake process, so we can indicate is it right or not.
Yeah, and it's ready to roast.
And it's ready to roast, of course. And then we have on each device that is rotating, that is moving, we have a speed monitoring system. To validate, is this device running or not? Is there a blockage anywhere? Is a mechanical failure? Is there an electrical failure? Every drive at the drum, at the stirrer of the cooler, the bucket elevator to remove the coffee from the cooler, these are all monitored by the speed monitoring system. When we're talking about the drum, then we of course have an under pressure atmosphere there in. We need to validate, is the pressure at the right value? So for this instance, we have the pressure monitoring built in. And of course, a lot of thermocouples to measure the roasting air. We have a thermocouple to measure the cooling air. We have a thermocouple to validate is the bean temperature, the product temperature, and of course the temperature inside the drum, the atmosphere, which is very important. Then the direct connection to the recipe.
Yeah. Where the magic happens.
Where the magic happens, right? So this is very, very important.
Yeah.
To go on, process efficiency, process control. But when we're talking about thermocouples, these are also relevant for the quality assurance.
Yeah.
And then, of course, quality assurance, flow sensors in the piping system to be on the right side. That we have no blockage, that everything is going well there. And then when we're talking about quality, we need to highlight, of course, we have talked about that a lot of times in the past, and we have done a dedicated heat session for that. It is color control.
Yeah.
The innovative color measurement system where we can measure the specific point of the roast status of the beans, which is also just a sensor, but an intelligent sensor, which helps us to get more knowledge out of the roasting process and to combine that with an intelligence in the digital world. Let's say that. So also very, very important. We can reduce waste because we can exactly roast on the right color. We want to have, we are independent of any individual with an individual decision where we can when to stop the roasting process or something like that.
Yeah.
A next very important sensor is the moisture sensor, which is also built in the roasting system, not direct on the roaster.
But in the destoner, yeah.
In the destoner, yes, right. Also, very, very important, a hidden sensor, but it becomes more interesting in the last decades.
Yeah.
Because we have a fixed target limit of 5% of moisture at the end of the
packaging, yeah.
The packaging, right? And we can have a direct influence in the coffee roasting on these target value.
Yeah.
And so getting closer and closer to the 5% is at the end pure money.
Yeah.
So it is important to know which moisture we have after roasting, and maybe if there are any deviations, we can adjust the roasting process to get closer to this target value. And then we were talking about machine availability, but also we are talking always about tangible and intangible assets, and we're talking about safety for the building, safety for the humans, the operator, etc. One very, very important system is a CO measuring system.
Yeah, sure.
So we are measuring, or the CO measuring system is an indicator or indicates if we have an explosive atmosphere in the piping coming from the roasting process. And also there we are continuously measuring the level of CO concentration. And we have then 2 target values or limit values. So if the first limit value is reached, we can end the roasting process, but after that it is all shut down because of maybe an occurring safety issue. And then we have a second value, and if this is indicated, the entire process is shut down immediately. And then we have emergency water, etc.
Yeah.
And it is all to avoid an explosion.
Yeah.
And at the end, to protect tangible and of course intangible assets.
Yeah, sure. And the roaster is the heart of the plant, and so you want to protect it by each and every standard there is. Yeah. I guess.
Yeah. And then when we're talking about machine availability from the maintenance perspective or the maintenance view, it is also important to know how are the drives running. So we have a bearing monitoring system to know what is the temperature. Is there any mechanical failure or issue there? Do we need to replace them? Yeah. So every moving, rotating part is indicated by a bearing monitoring system.
Yeah. That checks for vibration, I guess.
Yeah, vibration is then of course vibration. A dedicated vibration monitoring we have implemented at the fence. Yeah, it's the same. We can measure are there any imbalances or something like that, where we can have information. This fan is going to be broken in the next weeks or hours or something like that. Yeah. And then when you just mentioned the filter system, we have also a chaff blocking monitoring system in the cyclones. So as you all know, in the roasting process, there are a lot of shafts flowing to the pipes, and we separate them then in the cyclone, and it could be that there will be a blockage in the roasting cyclone. And this is also dangerous because we need to empty that. Yeah. But this system helps us to know if or whether there is a blockage or not.
Yeah. 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 So this is not a sensor that makes your life easier, but protects your machine and then makes your lives easier.
Yeah, it's better to have that instead of not.
Yeah, having the system being down because of chaff not being conveyed out of the system.
Yeah, right. Okay, do you want to move on?
Yeah, sure.
Yeah?
Sure. Thanks for the in-depth showing into the roasting system, which is our main product at PROBAT.
I mean, it's just an overview. We can talk about these
for
ages, and this is just an overview. So if you are interested in some of more details, please contact our engineering team or the sales area sales manager, and we can go in a more detailed way. This session is limited, though.
Yeah. So let me quickly wrap up with my last 2 points.
Yeah, of course.
We see 2 more points on the map, and I would like to at least quickly go into the next point, which is the grinding area, and we picked the grinders out, which also is a main component for us here at PROBAT. And the grinders we build, or our partners at Bauermeister build, they are just the pinnacle of coffee grinding. And also we rely on a lot of sensors inside the system to deliver the best quality of roasted coffee, and then even the ground coffee we can be thinking of. And for this we monitor a wide array of different things, which are temperature, because the rolls need to have a specific temperature, and being water cooled, the rolls, when they deviate in temperature, the spectrum of the grind changes. And for this we monitor the temperature and take measures to always keep the temperature in the right area. Then we have the particle size analyzing tool, which we are actively working on, and which is in development right now, which is an optical sensor that measures the final ground coffee and then gives a feedback loop into the control system, where we then can make changes to the running process in inline processing to reach the final target values, and for you as the customer to hit your quality parameters. And then we also have the position detection. So when you adjust the grinder, we have an active gap adjustment system that always knows its position, where it is in space, and regarding one roll to the other, always knows the exact distance. And even when grinding for a long time, then some grinders tend to see a drift of the rolls separating. Not with our system and not with our sensors we put in place to eliminate such deviation in the process.
So this specific sensor helps to continuously have the right gap or the control the gap. To guarantee and continuously quality.
Yeah, sure.
Okay, perfect.
Sure, it's the main goal to always have the desired grinding spectrum being put out of the machine, and this is one of the ways we achieve this goal. Then let me quickly, being on the topic of ground coffee, switch over to the last point inside the presentation, which is the ground coffee area. Here we also find some processes. Here we have a process that is called degassing. I'm sure a lot of you know that by grinding the coffee, a lot of CO2 gets in the atmosphere, and we need to get rid of some of the CO2 for the coffee to be able to be packaged and shipped then out to customers. And for this we have a degassing process we can actively monitor and regulate by sensors that measure the CO2 content of the air and even the oxygen content of the air, and then have a controlled system behind it to keep degassing times as low as possible, whilst also measuring for the exact target value, so we are sure that the coffee can be processed and packed and sent out to customers.
Mm-hmm. Perfect.
This is the last point that I wanted to make. It's a quick run through the whole.
Just the highlights.
Yeah, just the highlights, but a quick run through a whole coffee plant process. You will find maybe in your own coffee plant or have been to a coffee plant, and
But also some points we can develop on.
Yeah,
when
sure.
When we're talking about moisture measurement or I guess color control.
Yeah.
So
lots of open point for innovation.
Yes, right.
Yeah.
And innovation is the right word to close, I guess, this session, because what we have seen and hear today is the present status of a modern coffee roastery, but in our mind, we are 1 or 2 or 3 steps in the future, and maybe we can have a few sentences and words on what happened next.
Yeah.
And we're talking about smart factory, industry 4.0. These are all some buzzwords.
Yeah.
But they give the direction of what we need to achieve to have a modern and a future-proofed roastery.
I mean, they are buzzwords, but it's what you make out of them what counts. And as we try to illustrate just briefly today, we are actively adding more and more intelligence into the roasting plant, which enables the way to a smart factory, which you already dropped the buzzword of.
Yeah. And for us, a smart factory is then addressing an employee-free factory, maybe.
Yeah, lots of factories. Okay. I think we had some issues with the sound or the microphones. I hope everything is fine, and I think we are already had enough time to talk about the hidden sensors and the champions of the control system. I think we should maybe now wrap it up. And
we stopped at smart factory and an outlook for the future.
Yeah.
And just a sentence. So we of course at PROBAT we want to achieve the highest level of intelligence, to get more information. Then of course artificial intelligence is also a buzzword. What we want to implement in the future, to get more and more information, and to use these information at the right time, on the right place, and to get the additional value in the direct way to the customer, to increase their level of safety, the level of efficiency, the level of quality, but also we want to go the next step forward to a more automated maintenance concept. So a buzzword, next one is predictive maintenance, something like that. So for our customers, I guess it will be an interesting future, an innovative future, a future of a lot of digital little gizmos, and all surrounded by our self-developed software solutions. And I guess we are now at the end of this session.
Okay.
Thank you, Julian, for having this nice discussion.
Yeah, thank you, Mark.
Thank you to all of you, of the viewers, and of course of our customers. We are facing now the end of the year, and we were facing the Christmas time. We are already in the Christmas time. Thank you for the year. Thank you for interacting with us. Thank you for joining us on several exhibitions around the globe. We are looking forward to the next year, and we are happy to see you all in Emmerich, all on any place on the world, and to interact with you. And so we wish you all and your families a nice Christmas time and a happy New Year. Goodbye from Emmerich.
Yeah, goodbye.